Hey guys, today we are going through the next part of the Alleyn School Maths sample paper. So let's get straight into these solutions. Okay, so here for this next question, part A, we're told on a train there are 140 men and 200 women. What is the ratio of men to women written in its simplest form? So men we can call M, women we can call W. We have 140 to 200. So first of all, we can take out the common factor of 10, which gives us 14 out of 20. Then we can take out the common factor of 2, just like in fractions. And doing that, well, 2 times 7 is 14, and 2 times 10 is 20. So the ratio in its simplest form would be 7 to 10 men to women. Now for part B, we're told that we're making a scale model of the Eiffel Tower, which in real life is meant to be 120 meters tall, okay? Very tall. But for our scale model that we're going to make, we're going to use the ratio 1 to 50. So therefore, how long will our scale model be in centimeters? So let's break this down. There are a few different parts to this question. First thing is understanding that we're going from meters here to centimeters. Okay, so let's be mindful of that. Now, the second thing we need to notice, which makes this question, is the ratio, right? We have 1 to 50. And that's telling us that in real life, so we have model to real life. So in real life, what would actually be 50 meters, we're going to only represent it as 1 meter in our model. And knowing this, we can put the 120 meters, which is the height of the actual real life Eiffel Tower. And we can work out how many meters the scale model must be. Well, let's think about it like this. When it comes to ratios, we can either scale it or keep it consistent in the vertical direction, or we can keep it consistent in the horizontal direction. We can use a different color here. So either vertically or horizontally. In this case, it may be easier to make it consistent horizontally because we know we're trying to work out this value here. But we also know that going from 50 to 1, we divide by 50. And therefore, going from 120 to our mystery value, the scale height of the Eiffel Tower, we're also going to divide by 50. So really, to work it out, all we do is 120 divided by 50. And now we have familiar territory. Fractions. Take out the common factor of 10 or cancel the zeros. Then we have 12 over 5. We can work this out. 12 divided by 5. Well, 5 goes into 12 twice, giving us 10. And then we have 2. And then we can't put 5 into 2 wholly. So we add decimal point, add a 10 here. And 5 goes into 20 4 times. So it's 2.4 meters. That's the mystery value. But as we said at the start, how long will the model be in centimeters? This will be 240 centimeters because there are 100 centimeters in a single meter. So we times it by 100. So our answer is 240 centimeters. And now for part C, we're told my friend Sanjay is making a scale model of the London Ear. I haven't heard of that one before. A famous landmark in London. The London Ear is 80 meters tall and his model is 150 centimeters tall. What is the scale of the model in its simplest form? Okay, so here again we have the ratio, and we're looking at model versus real life. So let's try and plug in some values. In real life, we know the Londoner is 80 meters tall, and it's in meters, right? Be very careful about this. And in the model, we've modeled this by making it 150 centimeters tall, which is 1.5 meters tall. So now they're both in meters, and we know the ratio is 1.5 to 80. But let's turn that into its simplest form. We have 1.5 to 80. Let's get some more room. Let's first get it into whole numbers by multiplying both sides by 2. Now we have 3 to 160 model to real life. And since we can't go any further than that, that is the simplest form of this ratio, right? We can't divide 160 by 3 wholly into only a whole number. And therefore, the simplest form of this ratio is 3 to 160 model to real life. Okay, so now we're at question 19. So let's keep on going through this paper. Here, if we read the question, we're told that after some gardening, a cane went from 2.05 meters long to 156 centimeters long. And we need to work out what length of the cane was snapped off. And we do this by converting both to centimeters, because that allows us to compare these values a lot easier. So converting 2.05 meters to centimeters, we multiply by 100. So it's 205 centimeters. So now we have 205 minus 156, and we can work out what length was snapped off. Well, we have 5 minus 6, which we can't do, so we take a 10 from 2, to take a 10 from the 10, giving us 15 minus 6, which is 9. Then we have 9 minus 5, 4, 1 minus 1 is 0. So 49 centimeters is our answer. And now for part B, we're told that in her garden, she's sowing some grass seed, and the whole garden has an area of 158 meters squared. Each packet is only enough to cover 12 meters squared. So we need to work out how many packets that she needs to buy. So here it's simple division. We have 158 divided by 12. Well, 12 goes into 15 how many times? Once. Remainder 3. And 12 goes into 38 how many times? It's going to be 3 times, because 12 times 3 is 36. But the problem here is that this leaves a remainder of 2. And if we're trying to cover the whole garden, we can't have any remainders. We have to buy more than enough. And therefore, she won't buy 13 packets. She'll buy 1 more to make sure there's no remainder, which means she'll buy 14 packets. So now for question 20, we have a nice little scenario about Farmer Giles and his cows and counting the total number of legs. We're already told that if there's only 1 cow, there will be 6 legs in total, 4 from the cow and 2 from Farmer Giles. But how does that increase when we have 2 cows, 4 cows, 10 cows, 100 cows? Let's fill in this table. So 2 cows, well, it's going to be 2 times the 4 legs, which is 8. Add the 2, which is 10. What about 4 cows? Well, it's going to be not 2 now, but 4 times the 4 legs, which is 16. Add the same 2, which is 18. What about 10 cows? Well, it's going to be 10 times the 4 legs, which is 40. Add the 2, which is 42. What about 100 cows? And notice which numbers we have to erase and which numbers we can leave in place. For number of cows, it's going to be 100 cows times the 4, 400. Add the 2, 402. So now we've filled this table. We're trying to write a formula that links the number of cows, C, to the number of legs, L. Fill in the gaps to help her. So L equals something times C, number of cows, plus something. What numbers did we leave alone when we were working out the total number of legs as the number of cows changed? No matter what, we will always multiplying by 4 because a cow has 4 legs. And then we will always adding on 2 for Farmer Giles, who has 2 legs. So even if it was 1,000 cows, it will be 1,000 times 4, or 1,000 times the number of legs which the cows have, which is 4, added on to 2 for Farmer Giles. So here it's going to be L, or legs, equals 4 times the number of cows plus 2 to accommodate for Farmer Giles. And let's check it. Let's just make sure that we're correct by using some of these values in the table. Let's take this one here. So here, writing this out, we have L equals 14, number of legs in total. And this should equal 4 times C, number of cows, which is 3, add 2. And indeed, 14 equals 4 times 3, which is 12, plus 2. So our formula is correct. L equals 4C, 4 times the number of cows, plus 2. Okay, for this next question, again, we have a few steps. So let's take it methodically, step by step. On my wall, I want to put some stickers of my favorite pop star, Singing Steve. Okay, the space I have available is 55 centimeters by 60 centimeters. So let's visualize this. This is the total space we have available. And each of these stickers of the favorite pop star, Singing Steve, are 15 centimeters by 5 centimeters. So we have smaller stickers that we're trying to put onto the wall. How many of these stickers can we fit? So we need to work out the area of each of these 2 bits and bobs. So the area of the wall, and then the area of the stickers. And then we can simply divide the area of the wall by the area of the stickers to work out how many of these stickers can fit onto the wall. So let's start with the area of the wall. We have 55 times 60. Well, let's use our mental maths. 55 times 60 is simply going to be 55 times 6 multiplied by 10, or just add a 0. So 55 times 6 is what? Well, 50 times 6 is 300, because 5 times 6 is 30. So 50 times 6 is 300. And then 5 times 6 is 30. So we have the 300 plus the 30, 330. But now, since it's not 55 times 6, but 55 times 60, it's not 330, it's going to be 3,300. So that's the area of the wall using mental maths. I told you it was quicker. And then we have the area of the stickers. Here we have 15 times 5. Well, 15 times 5, 10 times 5, because notice 15 again is 10 and 5. So 10 times 5 is 50. 5 times 5 is 25. 50 plus 25 is 75. So we have 3,300 divided by 75. Okay, so how are we going to work this out? Here, we could use long division, or we could do something a bit more stealthy that could save us some time. Maybe we're running out of time and we need to work this out very quickly. 3,300 divided by 75. Watch this. This could be a scholarship level question. So we have 3,300 divided by 75. Okay. And instead of wasting time going the long way around and doing long division, we could simply recognize that 75 is half of 150, right? 75 times 2 is 150, and times that by 2 again is 300. So effectively, 75 times 4 is 300. Now, how many 300s go into 3,300? That's a bit more simple to do using our mental maths, right? Because 300 times 10 is going to be 3,000. But then to get to the extra 3,300, we need one more lot of 300. So overall, it's going to be 300 times 11. 300 times 11 gives us 3,300. But if 300 times 11 gives us 3,300, and 75 times 4 is 300, or 300 is just 4 times more than 75, that means if we're looking at 75s into 3,300 and not 300s into 3,300, it's going to be 4 times more. So instead of it being times 11, it's going to be times 11 times 4. Or in other words, it's going to be times 44. So 75 goes into 3,300 44 times. And that is a way to use mental maths to answer high-level questions efficiently and quickly. The answer is the maximum number is 44 stickers. And that can be the difference between getting the answer correct and finishing the paper versus running out of time. The mental maths. Okay, so that is all for today. Make sure you like the video, subscribe, and turn on notifications so that you're the first to know when the next video is released. And on that note, I will see you all next time.